Hi friends, good evening, good evening. Sorry for the delay. Am I audible, guys? Am I audible? Hi friends, good evening. Am I audible? Am I audible? Please let me know. Good evening, guys. Am I audible? Sorry for the delay. Some issues, laptop, went for updates and it took some time to get started. So, am I audible, guys? Anyone is there? Please do comment, and please do like, share, and subscribe. Please do share it with as many people as possible. So, guys, good evening, very good evening. If anyone is there, please comment. A very good evening, namaskaram, namaskar, ellarkum vanakkam. Namaskar, good evening, good evening, good evening. Anyone is there, please comment, guys. In previous classes, I have discussed RRB JE. Some objective questions I have discussed. In this, I'll be discussing SSC JE conventional questions. Through conventional questions, we try to discuss, uh, you know, we try to discuss concepts as well. So, if anyone is there, please comment. Please comment, guys. Please comment. Please comment. Please comment. Please do like, share with as many people as possible, and subscribe as well. I think this is the time where people go for their dinner. So even I can't comment saying that you should be available all the time. Please to join for the live, and these are free classes. The major idea of this is to motivate you and to give you confidence to brush up your basics and to go through the classes. As I said previously, we are just a guiding light. We are nothing much. We'll just show you the light. In that light, you have to travel. It's your hard work, right? So that's what matters. We'll wait for another 3 more minutes so that if people comes, we'll start the class. Even if not, also we'll start the class because the idea is to start the class. You might come later and watch, so I don't want to waste your time there. So please do comment, guys. Please do comment. So what's happening recently? What is happening in your life? I would like to, tell a small short story regarding two people. Uh, Both are my students only. So it goes like this: a person who started, let us say, preparation 3 years back. At the same time, other person also started preparation. So both of them didn't clear the gate. Namaste, AJ. How are you? So both of them didn't clear gate examination of that year. So what happened? One person got some decent gate rank. So he got somewhere in some of the IITs and he went for MTech. Other person was not interested in doing MTech. So what he said, he'll go for another long term. The next long term also, I helped him to, once again we teach, no? We were guiding. And I guided this guy as well, who's went for IIT. And I told this guy, let see, MTech is like a second option. That should not be a primary option. Your primary option should be like preparing for competitive exams. But since he went to college life and MTech, he thought something will happen in the MTech life, and he left all the preparation behind. So he left all the preparation behind. Now what to do? And he got sidetracked. Other guy, he was like 1 year he prepared. This time also he didn't clear the gate, but he got some decent rank. Based on that, he got an IIT. This guy was not interested, but I forced him to go to IIT so that if nothing happens, some degree will be there with you. At the same time, constantly he was preparing for the exams. He has given his state exams as well. Then the next year he has given the gate exam as well. Finally, you know what? He cleared his state exam. He cleared his gate examination. He cleared his engineering services prelims. He cleared his engineering services mains as well. So now he has got different types of jobs with him, and at the same time, he is doing his MTech parallelly. He'll get his MTech degree as well. The other guy cleared MTech, but by using the MTech degree, what he is getting? He is getting nothing. He can just teach in some of the institutions for some decent money, but he is not getting job anywhere. So MTech will give you like a one of the option where if you do PhD only, then only MTech is useful. If not, it is not that much useful. Like so, you should be very much clear whether if you're going for PhD, do MTech. If you're not going for PhD, then you will be doing MTech only for stipend, nothing else. That is the practicality. Like that is one of the option, not it should not be one and only option. Because after 2 years of MTech, then once again you look for job. And once again you should start preparation. That is very, very, very lengthy task. That's not easy task as well. So if you ask me, you should be properly preparing for any exam. You should be clear about what you have to read, you have to read, and what you want actually, what you need, whether it is job, which type of job, or whether you're going to pursue PhD. Because you can't get sidetracked, and once again after 2 years you can't once again come and read all the questions and once again prepare. It is very, very difficult task to do. So I always advise people, please be clear with what you want. Please be clear. So jobs, if you're like into the jobs, then don't focus that much into MTech. MTech should be like basic thing, like you learn your basics over there, and you maintain your attendance, and you get your stipend. That's it. That's it. Because you're preparing for competitive exams. If you're not preparing for competitive exams, then do MTech very sincerely that you'll be able to do PhD in better institutes, like you'll go out of India, do PhD over there, then come back and join in India as professors. So becoming professors in IITs and NITs also fetches you good decent amount of money. But that is a far task, like it takes another 5 to 8 years. But if you do that, yeah, that is also good. Fine. So Arvind, you have given the answer. Fine, fine. Anyway, that is voice break हो रहा है. Voice is not clear. I thought it is clear. Now voice is clear. AJ, now voice is clear. Now voice is clear, AJ. अभी voice ठीक है क्या? अभी ठीक है, fine, fine. I was just saying some story. So please be clear of what you want and what you want to do in the future and all those things. Fine. Now, in this session, I'll be discussing conventional questions of previous years SSC JE. This is not for objective questions. Last time I have discussed objective questions with you. Now I'll be discussing conventional questions SSC JE. So here, the first question is design a rectangular beam section of width 300 mm, For a total service bending moment 200 kilonewton meter, use M20 concrete, Fe415 steel. Assume the exposure as mild. Design for flexure only. Flexure means you are going to design only for flexural reinforcement. You will not be designing anything for shear reinforcement here. Fine. So what is the width of the beam that is given to you? Width of the beam given to you is 300 mm. So width of the beam is given to you as 300 mm. Width of the beam is given to you as 300 mm. You have to design. Design means you have to find out what is the effective depth and what is the steel reinforcement. And is it given which type, what type of beam is given to you? Design a rectangular beam of section 300 mm width for a total service bending moment of 200 kilonewton meter. Use M20 concrete and Fe415 steel. Assume exposure as mild condition. Design for flexure only. Right. So just a minute, guys. Width of the beam is 300 mm. Idea is to find out first depth of the beam. So mu limiting. Mu limiting would be equals to, that means for depth of balanced section. Depth of what? Depth of balanced section, or I can also call this as limiting section. Depth of balanced section, mu limiting would be equals to 0.138 FCK BD square. 0.138 FCK BD square. So Given bending moment is 200 kilonewton meter. So what will be the factored bending moment? Factored bending moment would be equals to 1.5 times 200. That would be equals to 300 kilonewton meter. This is your factored bending moment, or you can also say bending moment, factored bending moment, or you can also take this as mu limiting. Mu limiting, I'll take it as 300 kilonewton meter. So if this is 300 kilonewton meter, then depth of balance section, depth of balanced, depth of balanced section, depth of balance section would be how we will calculate mu limiting equals to 0.138 FCK BD square. 0.138 FCK BD square. So here, what is the grade of concrete given to you? Grade of concrete given M20 concrete Fe415 steel. So M20 concrete, concrete is M20. So FCK would be equals to 20 Newton per mm square. So 300 kilonewton meter. So in terms of Newton mm, 300 into 10 to the power of 6, that is equals to 0.138. FCK is 20 and B is 300 mm multiplied by D square. From this, if you substitute, what you will get D. D, as AJ said, you will get it as 601.92. So you will get D as 601.92 mm. He said exposure condition as mild exposure condition. Generally for mild exposure condition, you will provide 20 mm. Mild exposure condition, you will provide cover as 20 mm, but I'll provide effective cover as 50 mm. I'll provide effective cover as 50 mm, and since this is D required is 601.92 mm. I'll provide D as 650 mm. So D provided. This is, see, these are design type of questions. You can provide anything. So nearby, more you can provide 600 mm, but I'm providing 650 mm. So 650 mm of D is provided. Overall depth would be equals to D provided plus effective cover. D provided plus effective cover. So that is equals to 650 plus 50. That equals to 700 mm. 700 mm. So your overall depth equals to overall depth would be equals to overall depth would be equals to 700 mm, and effective depth would be equals to 650 mm. Effective depth is 650 mm. Okay. So any doubts up to here? Any doubts up to here? Krupa, Raju, hi Krupa, how are you after a long time? So any doubts up to here, guys? Any doubts up to here? Any doubts up to here, guys? How to find out depth? Any doubts? This is depth of balancing section. Any doubts up to here? Any doubts up to here? Please do comment. If you are there, please comment. Any doubts up to here? No? Fine. Now how we are going to find out AST? Area of steel required would be equals to 0.5 FCK BD upon Fy multiplied by 1 minus under root of 1 minus 4.6 mu limiting, the same mu that is given to you, 4.6 mu upon FCK BD square. 4.6 FCK BD square. Right? This formula you have to remember. You don't have a choice. You have to definitely remember. Right? AST equals to 0.5 FCK upon F by 0.5 BD FCK upon F by multiplied by 1 minus under root of 1 minus 4.6 mu upon FCK BD square. So please do substitute all the values that is given to you over here. So the values that is given to you would be, here it is 0.5, FCK is 20, B is 300, D just now we have found out that is 650 upon Fy is 415 Newton per mm square multiplied by 1 minus under root of 1 minus 4.6 mu. Mu is 300 into 10 to the power of 6 upon FCK. FCK is 20, 300 multiplied by 450 square. What is the value? 300 into 650 square. AST value approximately. This is not 450, this is 650 square. This is 650 square. Like 4.6 mu upon FCK BD square. Substitute everything in Newton per mm. Newton mm and Newton per mm square. When I am multiplying mu by 10 to the power of 6, because it is given in kilonewton meter, I am trying to convert that in Newton mm. That is the meaning over there. Fine. So finally, what is the value of AST that you will get? Please do substitute and let me know. AST value. So AST, Arvind is saying it is 1644 mm square. So approximately what I can provide? If I take 20 mm dia bars, number of 20 mm dia bars. Number of 20 mm dia bars would be equals to AST upon pi by 4 into 20 square. Pi by 4 into 20 square. So 20 square. AST is 1644 upon pi by 4 multiplied by 20 square. So how many number of bars? AJ, how many number of bars? How many number of 20 mm dia bars? 6 bars. You're getting it? What is this value that you are getting? He's saying this approximately as 6, something around 5.1 you are getting. What is the value that is you are getting? 6 bars. Fine. So you are getting 6 20 mm dia bars. So here you are getting depth, overall depth as 5.23, okay, approximately 6. Overall depth as 700 mm and AST equals to 6 numbers of 20 mm dia. 6 numbers of 20 mm dia. What is AST minimum? AST minimum would be 0.85 upon Fy multiplied by B into P. What is the value of AST minimum? What is the value of AST minimum? Please give me the answer. What is the value of AST minimum? When I am saying small d means 650 mm. Capital D, overall depth is 700 mm. What is the value of AST minimum? And similarly, what would be AST max? AST max, what is the formula? 0.04 B into D. So what is the value of AST max and what is the value of AST minimum? What is the value of AST minimum and what is the value of AST max? AST minimum you are getting 400 mm square. AST max, you can use calculator over here. These are conventional questions. You are supposed to use calculator. Without that, you can't solve these questions. I am discussing conventional questions over here. This is not for RRB JE, or this is not for objective questions. This class is exclusively for conventional questions. AST max is 8400 mm square. So you, whatever the AST you got, it is in between AST minimum and AST maximum. Therefore, our design is safe. Our design is safe. So AST provided, whatever the AST provided. Right? So this is how you calculate. AST provided is in between AST minimum and AST maximum. So from this you can clearly say that our design is safe. So whenever they ask you to find out what is the beam section width, and when a bending moment is given to you, the very first thing is we always try to design it as limiting section, because we don't know whether it is over reinforced or under reinforced. So the better thing to do is we'll try to provide it as limiting section, and you can check it. So based on this, what you can say is, so what is the limiting depth? Limiting depth, if you want to calculate, so first you calculate mu limiting. From mu limiting, zero point 0.1, here it is based on limit state method. This is not WSM, this is limit state method. So mu limiting would be equals to 0.138 FCK BD square. From that you got D as 601.92 mm. So but you'll provide D as 650 mm. You can provide 600, but since to provide more, I'll provide 650. 625 also you can provide 650. I am providing mild exposure condition. For mild exposure condition, cover should be 20 mm. So I am providing effective cover as 50 mm. So overall depth is 700 mm. So once you find out overall depth, now how you are going to find out AST required? AST required would be equals to 0.5 FCK BD upon F5, 1 minus 100 of 1 minus 4.6 MU upon FCK BD square. This is for under reinforced section. Obviously, if you are providing more depth, it means indirectly we are designing it as under reinforced section. So AST we calculated, we got somewhere around 6 numbers of 20 mm dia bars, and we have to check whether it is in between AST minimum and AST maximum or not. So AST minimum, formula for AST minimum would be, so AST minimum formula is 0.85 upon F5 multiplied by B into D, and AST maximum would be 0.04 times B into capital D. So AST provided should be in this range, then only your design is correct. Fine. Any doubts in this, guys? Please do comment. If not, we'll go to the next question. Any doubts in this? Any doubts? Sir, by discussing conventional questions, I am discussing the concept also over here. Here, this is one question where they'll ask what is the AST minimum, and this is another question, what is the AST maximum. And sometimes in the question in the gate also they'll ask what is the factored bending moment, given bending moment, and what is factored bending moment they'll ask. And they'll ask how you are going to find out the depth. Mu limiting equals to 0.138 FCK BD square. From that, how you are going to find out depth required, and overall depth, how you are going to find out. So all these things is discussed in one single question. Fine. Now, going to the next question, find the moment of resistance of the beam section of 20 centimeters by 60 centimeters deep. If it is reinforced with two 20 mm dia bars in compression and tension, each at an effective cover of 50 mm, use M25 mix and Fe415 grade steel, and FSC. Stress in the steel, you can compression steel, you can take it as 354 Newton per mm square. 354 Newton per mm square, you can take that as the stress in the steel. Try to Arvind, try to solve this. Find the moment of resistance of beam section of 20 centimeters by 60 centimeters deep, overall depth, or you can take that as effective depth. If it is reinforced with two 20 mm dia bars in compression and tension, each at an effective cover. Effective cover is also given to you. use M25 mix and Fe415 steel. FSC, you can take it as 354 Newton per mm square. Sometimes charts will be given to you. If charts is not given to you, they will directly give you the value. What is the value of FSC? You can do that. And if you don't remember, then generally it is in the range of 354, or it depends upon D by D ratio. But approximately 350 also you can take. But here, in this case, 354 Newton per mm square is what you generally take as FSC. So please try to solve it. I'll give you 5 minutes of time. Just try to analyze the question. Whenever a question is given to you, conventional questions mainly, first you have to analyze the question. Take your time, so 2 to 3 minutes. Read that question once, twice, because conventional questions are like very tricky, very tricky. So try to solve it. Beam of Find the moment of resistance of beam of section 20 centimeters by 60 centimeters deep. Overall depth is 60 centimeters, and this is 20 centimeters by 60 centimeters deep. Overall depth is 60 centimeters. In examination, you think that there won't be any time for conventional questions. No, for conventional questions, there will be ample amount of time. For objective questions, sometimes you may not have time, but for conventional questions, there will always be decent amount of time. 20 centimeters by 60 centimeters. If I have to erase, I have to erase overall. One second, I will draw. 220 dia bars on both compression or tension side. I think AJ is trying to solve the question. 60 centimeters means 600 mm, not meters, 600 mm, and this would be 200 mm with this 200 mm. Effective cover on both the sides 50 mm, and effective cover over here also is 50 mm. And always remember, you will get some marks. If you attempt, you will get some marks. It's not like college exam where you'll write some nonsense stories and you'll get the marks. No, it doesn't work that way. If you attempt the question, then definitely you'll get some marks. So overall, D equals to 600 mm. Some people will take that this has 600 mm, and I mean effective depth has 600 mm, 50 mm effective cover they'll provide. That is also sometimes correct, but if you want full marks, then you have to give it something like this. Effective cover would be equals to, so effective depth would be 600 minus 50. So effective depth is equals to 550 mm. Effective depth is 550 mm. And AST and ASC both are 220 mm dia bars. 220 mm dia bars, right? So we are discussing only flexor over here. We are not discussing any steel. Ajay Rajput, how are you? So, Rajput, you're from Rajasthan. Rajasthan, Jaipur. So D equals to 550 mm. Effective depth is 550 mm. Now, just try to calculate what is AST. AST would be equals to 2 multiplied by pi by 4 into D square, that is 20 square. That is same. ASC is also same. ASC is also 2 multiplied by pi by 4 multiplied by 20 square. This is AST and ASC. Both are same. First, your idea should be first how you are going to find out whether this is under reinforced, over reinforced, or limiting section. For that, first you have to find out what is XU limiting. XU limiting. XU limiting would be equals to, if it is FE 415, we can simply take it as 0.48D. XU limiting equals to 0.48D. So that is 0.48 multiplied by effective depth is 550 mm. What is this value? XU limiting. XU limiting, what is the value? XU limiting, what is the value, guys? 0.48 multiplied by 550. Ajay Rajput, we are discussing SSC conventional questions over here. SSC JE conventional questions I am discussing over here. So 0.48 times D, 0.48 times 550. What is the value? 0.48 times 550. 0.48 times 550. You can also solve with me accordingly. There is no issue. What is 0.48 times 550? XU limiting. XU limiting. What is the value, guys? 0.48 times 550. You need to calculate. So this would be somewhere around 0.48 multiplied by 550. 264 mm. XU limiting would be 264 mm. And how you're going to find out XU, actual depth of neutral axis? For finding out actual depth of neutral axis, you have to equate C equals to T. Compressive force must be equals to tensile force. What is compressive force? 0.36 FCK B into XU plus there is compression steel, that is FSC, minus 0.45 FCK multiplied by ASC, that is equals to 0.87 Fy multiplied by AST. 0.87 Fy multiplied by AST. Right? 0.87 Fy multiplied by AST. XU limiting is 264. Fine. 0.87 Fy multiplied by AST. What is the value of AST and ASC, guys? Both are same, I think. What is the value? Pi by 2 into 20 square. What is the value of AST and ASC? You tell me, I'll write it over here. 0.36 FCK is 25, B is 200 mm, and you have to calculate XU plus FSC. I told you you can take it as 354 minus 0.415 in multiplied by 25. What is the value of ASC? Please let me know. And that is equals to 0.87 Fy is 415 multiplied by AST. What is the value of ASC, guys? ASC and AST, what is the value? What is the value? Please do like, share with as many people as possible. This is conventional questions. Conventional questions will be solved like this only. Each question will take up to 15 to 20 minutes to be solved. Fine. So what is the value of AST and ASC? AST, you don't have calculator with you? 20 multiplied by 20 multiplied by, I don't have calculator here, pi by 2, 628.318. If I'm not wrong, it is 628.318. 628.318. Yeah, 628. AC would be equal, AC or AST would be equals to 628. 628.318. You can take it as 628. From this, what is the value of XU you are getting? Please tell me what is the value of XU. Solve this equation and let me know what is the value of XU. What is the value of XU, AJ? Doubly reinforced beam. Arunachal Entertainment. Arunachal. Yeah, you just joined the session. Yeah, it is doubly reinforced. Doubly reinforced beam Arunachal. So you're always welcome. Whenever you join, you can start. You can just go through some previous 5 to 6 minutes. You'll get the question, and I am solving this question. It's a doubly reinforcement beam and doubly reinforced beam, and here we are trying to calculate what is the moment of resistance. Moment of resistance, before that you should calculate whether it is under reinforced section, balanced section, or over reinforced section. For calculating under reinforced section, for calculating this, first I have calculated XU limiting. XU limiting is 0.48 times D. 0.48 times D is 550 mm. And for calculating XU, actual depth of neutral axis, I have equated C equals to T. And so 0.36 FCK B into XU plus FSC minus 0.45 FCK ASC equals to 0.87 FY into AST. This is doubly reinforced section. So from this, what is the value of XU you are getting? Please let me know what is the value of XU. I think AJ is there from the starting. I am expecting you to answer what is the value of XU. I don't have calci. Please to calculate what is the value of XU. Based on that, we'll come to know whether it is under reinforced or over reinforced section. 6.59 mm. So you are getting XU as 6.59 mm. So XU limiting is how much you got? 264 mm. XU is less than XU limiting. So this is under reinforced section. XU is less than XU limiting. You can take it as under reinforced section. You can take it as under reinforced section. Now if it is under reinforced section, what is the value of MU limiting or moment of resistance? MOR, moment of resistance, would be equals to 0.36 FCK B multiplied by XU multiplied by D minus 0.42 XU plus FSC minus 0.45 FCK multiplied by D minus D dash. Is that D dash is the effective cover of compression reinforcement. Effective cover of compression reinforcement is how much? Effective cover of compression reinforcement, this is D dash. Effective cover of compression reinforcement is also 50 mm. So if you try to substitute it over here, XU is less than XU limiting. So here it is under reinforced section. So this is 0.36 FCK B into XU. 0.36 FCK is 25, B is 20. XU you got 6.59 mm and D you are taking it as 550 minus 0.42 multiplied by 6.59 plus FSC is 354 minus 0.45 multiplied by 215. Sorry, not 215. It is multiplied by FCK is 25. And here there is ASC also. Sorry, here there is ASC. ASC is 628 multiplied with D is 550 minus 50. 550 minus 50. Substitute, you know all the values. 0.36 FCK B into XU multiplied by D minus 0.42 XU. You are not substituting XU limiting here. You are just substituting XU over here. 0.36 FCK B into XU D minus 0.42 XU plus FSC minus 0.45 FCK multiplied by ASC multiplied by D minus D dash. See, I am solving this based on limit state method. If nothing is mentioned in the question, you solve it by using limit state method. If they want you to solve by WSM, working stress method, they'll mention use WSM, they'll mention. If not, you have to solve it by limit state method. So moment of resistance Moment of resistance, Arvind is saying he got somewhere around moment of resistance equals to 113.89 kilonewton 113.89 kilonewton meter. That is moment of resistance. Moment of resistance is 113.89 kilonewton. Fine. Any doubts in this, guys? Any doubts in this? 113.89 kilonewton meter. Any doubts in this? So what we have done over here, our idea is to calculate what is XU limiting and XU. Whether XU is less than XU limiting, XU is more than XU limiting. Based on that, what type of reinforced section, what type of section it is, under reinforced section, uh, balance section, or over reinforced section. Under reinforced section, balance section, or over reinforced section. So if it is under reinforced, for that you have to calculate XU limiting and XU. And XU limiting for FE415, it is calculated as 0.48 D, and XU is calculated as by using C equals to T, you will calculate XU. From that, if XU is less than XU limiting, here we got XU is less than XU limiting, it is under reinforced section. Based on that, we calculated moment of resistance. Fine. Any doubts? If AJ is saying no, no means no. Next question. Please try to solve this question. I'm just getting a call. I'll just attend and come in just 2 minutes. Okay. Please try to solve this question. Just a minute. Just a minute. Please pardon. Sorry for the disturbance, guys. Sorry for the disturbance. So please try to solve this question. A reinforced concrete beam of 30 centimeters by 60 centimeters in section is reinforced with four numbers of 4 bars of 16 mm dia at the top and 5 bars of 22 mm dia at the bottom with an effective cover of 4 centimeters. Assume safe compressive strength of concrete as 50 kgs per centimeter square and sigma SE, that is strength in the steel, that is 1400 kgs per centimeter square, M equals to 19, and find the moment of resistance. See, they have mentioned WSM. WSM means you have to solve this by using working stress method. Working stress method. So idea is to find out moment of resistance only. Moment of resistance means same thing. You have to calculate whether it is under reinforcement section, balance section, or over reinforced section. And but this is by using WSM, working stress method. The beam dimensions that is given to you is 30 centimeters by 60 centimeters. That means 300 mm by 600 mm. And effective cover that is given to you is 40 mm. 40 mm is the effective cover that is given to you. 40 mm is the effective cover that is given to you, and reinforced with 4 bars, 4 16 mm die bars, 1 2 3 4. So 4 16 mm die bars in the compression and 5 20 mm die bars at the tension. So ASC, if they ask, that equals to 4 multiplied by pi by 4 multiplied by 16 square, and AST would be equals to 5 multiplied by pi by 4 multiplied by 22 square, 22 mm diabars. So ASC AST value is we can find out, and sigma CBC is 50 kgs per centimeter square and sigma SC is 1400 kgs per centimeter square. Try to convert that into Newton per mm square as well. You have to convert. You don't have a choice. Approximately, you can take it as 5 Newton per mm square, and this you can take it as 140 Newton per mm square. Approximately. Don't you think so? Because 1 kg is 0.1 newtons, and centimeter square, if you try to convert into Newton mm square, that would be equals to 100 mm square. Try to solve it, guys. Hmm? Fine, I'll solve this with you accordingly. Uh, Parallelly. Parallelly, both of us will solve. Just let me know what is the value of ASC and AST, and what is given to you over here. Safe compressive strength, that is CBC. Sigma CBC equals to 50 kgs per centimeter square. Approximately, you can take it as 1 kg is 10 newtons and this is 100 mm square. So approximately this is 5 Newton per mm square. If you are taking it as 9.8, then you'll get somewhere around 4.9. But anyway, approximately I'm taking it over here. Sigma ST, that equals to 140 1400 kgs per centimeter square. Obviously, you have to solve. Why you'll write that in the examination that a quadratic equation has to be solved? Solve and give me the value. You have to solve a quadratic equation over here and try to find out the value of x. I mean, actual depth of neutral axis. Don't expect everything to be spoon fed to you. Okay. Solve that quadratic equation and let me know the value. This is sigma CVC and sigma ST. And what is the value of m given to you? M is given to you as 19. Time taking means, what will you do if even though if it is time taking, you have to solve AJ. In examination, what will you do? You have to solve. Of course, it is time taking, but you have to solve. No. What is the other choice that you have? AST is 1900.66. ASC is 804.25. Arunachal has given to you. This is your previous year's question only. I am not saying that this is your. I mean, I am not giving taking that question from the textbook. This is your previous year's question only. This is 804.25 and this is 1900.66. AST and ASC. M equals to 19. What is depth of neutral axis? Generally, it is given as NC. No, depth of neutral axis is M upon M plus R multiplied by D. R would be equals to sigma ST upon sigma CBC, that is 140 by sigma CBC is 5. So this is value 5 2s are 10, 5 2s are 10, 40, 28. M value is given as 19. So 19 upon 19 plus 28 multiplied by D, effective depth. Effective depth is 600 minus 40. This is your effective depth, 600 minus 40, that is 560. 560. 600 minus 40, this is 560. See, in some places you will see that 600 mm is taken as effective depth, and they'll be adding this 40 mm also. Both are correct. You can take 640 or you can take 600 mm as your overall depth and 560. Both, for both the cases you will get marks. Okay. So this is NC, that is limiting depth of or critical depth of neutral axis. What is the value of critical depth of neutral axis? 19 upon 19 plus 28 multiplied by 560. And anyway, quadratic equations you don't have to solve by hand, no? You can solve it by using calci. Just keep the values, you'll get the values in calculator. Why are you thinking too much? Anyway, what is the critical depth of neutral axis, guys? XC critical depth of neutral axis, you're getting it as 226.24 mm. 226.24 mm. Critical depth of neutral axis is 226.24 mm. Actual depth of neutral axis. Now, what you have to calculate? Actual depth of neutral axis, right? So, for actual depth of neutral axis, what you will be doing? You have to equate compression force that is equals to tension force. So it is generally given as, in WSM it is given as B into n square by 2 plus 1.5 m minus 1 multiplied by ASC, 1.5 minus 1 multiplied by ASC into multiplied by n minus dc, depth of the cover. For compression reinforcement also you will take 40 mm only, that is equals to m into, that is equals to m into ast. What is that you have written over there? M into ast, m into ast multiplied by d minus n, m into ast multiplied by d minus n, b into n square by 2 plus 1.5 m minus 1 ASC n minus dc, depth of the cover. So m into ast multiplied by d minus n. So this is how much? 300 mm. This is given to us 300 n square by 2 plus 1.5 multiplied by 19 minus 1. This is 804.25. People are saying this is 804.25 multiplied by n. N minus dc is 40 mm, and m19 multiplied by 1900.66 multiplied by d you can take it as 560 minus n. n value you have to calculate, right? Minus n. So what is the value of n that you'll be getting? What is the value of n? What is the value of n? So Arvind saying n value is 228.1 mm. And what is NC you got? NC equals to 226.24 mm. So actual depth. N is called actual depth. Actual depth of neutral axis. And NC is called as critical depth of neutral axis. Since n is greater than nc, n is greater than nc, this is over reinforced section. This is what? Over reinforced section. N is greater than nc. This is called over reinforced section. So since it is over reinforced section, moment of resistance. Our idea is to calculate what? Moment of resistance. So how will you calculate moment of resistance, guys? Let me know how will you calculate moment of resistance. See, over reinforced sections means first concrete fails, then steel fails. Right? First, what fails? First, concrete fails, then steel fails. So here, since it is doubly reinforced section, since it is doubly reinforced section, you have to calculate what is the stress at the level of compression steel, that is generally taken as C dash. So the stress strain diagram or stress diagram would be simply a rectangular face in a rectangular figure. In WSM, it is simply taken as rectangular figure, something like this. Not rectangular, triangular. I mean to say that it is a straight line. So simply it would be a straight line, something like this. It would be a straight line. So this is actual depth of neutral axis. I'll take this as N. Fine. Here the stress is C, sigma CBC or C. That I am taking it as 5 Newton per mm square. Now, at the depth of what? At the depth of compression steel, you must be able to calculating the stress, that is C dash. This depth is D dash. I'll write it as D dash. So how you are going to find out? You can write out C by N would be equals to C dash upon N minus D. So from this N value that you are getting is 228 something you got. So DC D dash, that is 40 mm. Substitute it over here and tell me what is the value of C dash. What is the value of C dash? What is the value of C dash? Please let me know the value of C dash, guys. Not MOR. What is the value of C dash? C dash, yeah, C dash. FSC or C dash over here is equals to 4.04 Newton per mm square. So C dash is 4.04 Newton per mm square. And finally, uh, moment of resistance. Moment of resistance would be equals to B multiplied by N multiplied by C by 2 multiplied by D minus N by 3 plus 1.5 M minus 1 multiplied by ASC multiplied by D minus D dash multiplied by ASC. What is the doubt? AC multiplied by C dash multiplied by D minus D dash. So B is 300, N is 228 something, C is 5 by 2 multiplied by D is 550 minus 228 by 3 plus 1.5 multiplied by 19 minus 1 multiplied by ASC. ASC is 804.2 multiplied by D is 550. Sorry, 560, not 550, this is 560, right? 560 minus 40. 560 minus 40. So what is the value of MO or moment of resistance that you are getting? You will get something big divided by 10 to the power of 6. Divided by 10 to the power of 6, so that you will get that in kilonewton meter. You will get that in kilonewton meter. So what is the value, guys? 126.67 kilonewton meter. 126.67 kilonewton meter. This is moment of resistance for over-reinforced section. In over-reinforced section, the first failure would be concrete followed by steel. Whereas in under-reinforced section, first failure would be from steel followed by concrete. But in any type of section, if you want to calculate moment of resistance, the best thing is to calculate from compression side only compared to that of tension side. So in this type of question, since they asked what is the moment of resistance, what we have done, a reinforced concrete beam is given to you. Once again, I am discussing this with you. A reinforced concrete beam of 30 centimeters by 60 centimeters in section is reinforced with 4 bars of 60 mm dia in compression and 5 bars of 22 mm dia in the tension with effective cover of 4 centimeters on both the sides. So 40 mm by 40 mm. CBC is given to you and sigma ST is given to you. M value, moment of resistance he has asked. Idea is to calculate what is the critical depth of neutral axis. Critical depth of neutral axis would be M upon M plus R multiplied by D. From that you will get critical depth of neutral axis, and you got somewhere around 226. I have deleted that. Okay, so please don't mind. And next one is to find out what is the value of actual depth of neutral axis. You just equate C equals to T and you'll try to find out actual depth of neutral axis. So here actual depth is 228.1, critical depth you got 226.24 mm. Actual depth is more than critical depth, so this is O reinforced section. O reinforced section. So here what we have calculated is, initially we have calculated C 5 Newton per mm square, and what is the value of C dash? Press over here. Since it is over reinforced section, first failure in the concrete, so C you can easily take it as 5 Newton per mm square, so I am taking it as 5 Newton per mm square. If not, if it is under reinforced section, you should be taking sigma ST, right? From that, based on that, you have to calculate C, but since it is over reinforced section, first failure is in the concrete, so C you'll be taking it as 5 Newton per mm square. First failure means first concrete reaches maximum, then steel. Okay, so C dash I have calculated from 4.04 Newton per mm square you got. From that, moment of resistance will be equals to B into N into C by T, D minus M by 3. I'm not giving you proof, you have to remember this. 1.5 M minus 1 ASC into C dash not C multiplied by D minus D dash, 300 into 228 multiplied by 5 by 2, 500 minus 228 by 3, 1.5, something like if you substitute, you will get 126.67 kilonewton. Any doubts in this, or if at all if you want me to repeat, please let me know. I'll repeat, or if there is any doubts in this, let me know. It takes some time. There will be quadratic equations. Use that in your calculator, you'll get the answers. Simply use that in the calculator, you'll get the answers. This takes time, but if you solve this, you'll get marks. Conventional questions are like this. So any doubts in this, let me know. Any doubts in this, guys, please let me know. Any doubts? Any doubts? Any doubts? Any doubts? In SOM, we neglected self-weight and RCC. We include Y. Is engineering based on assumptions? A big question. In SOM, we neglected self-weight and see, in strength of materials, it's like giving you an idea. In RCC, it's like application. Strength of metals will be same for both mechanical and civil, whereas in RCC it is application. You have to consider each and everything: self weight, dead load, live load, seismic load, earthquake loads. Everything you have to consider while designing. And of course, engineering's not only engineering. Everything in this world is based on some assumptions only, because practicality is quite different from what actually happening in reality. I mean, practicality is different from exact thing you can't replicate. Even if you take soil test also, many assumptions will be there. Even if your heart rate and whatever the medicines you're taking, all these things are based on some assumptions. That diabetes, cholesterol, everything is assumptions, not only in civil engineering. Everything is assumption. Every field is based on many assumptions. Okay. So try to solve this question. Design a reinforced concrete beam with balance section for flexor by using working stress method for the data given below. Effective span is 8 meters. Live load is 12 kilonewton per meter. Width of the beam is 300 mm. Grade of concrete is 20. Reinforcement steel grade FE415. Try to read the question for some time and try to analyze the question. Then we'll solve it. We do analysis in SOM and RCC we design. Simple answer. Arunachal Entertainment. What that type? Where are you from? You're from Arunachal Pradesh. Different names here. Arunachal Entertainment. So design a reinforced concrete beam with balance section for flexor by working stress method for the data given below. Try to read the question and try to analyze this first. Always you should take 5 minutes to analyze. You're from Arunachal Pradesh, huh? Far, very far from my place. I've never been to Arunachal Pradesh, but one day I'll definitely go there. Try to analyze the question, guys. WSM is somewhat time taking compared to that of LSM, but you have to be patient, very patient. Design means you have to calculate the depth and you have to calculate the steel. Two things you have to calculate. You have to calculate the depth and you have to calculate what is the steel. In first case, in a LSM limit state method, bending moment is given to you directly. Here you have to calculate the bending moment. So here the SOM concepts comes into the picture. Effective span. Effective span is given to you as L effective is given to you as 8 meters. L effective is given to you as what? 8 meters. And there is live load as well as dead load. But live load is given to you, dead load you have to calculate. So the first thing is, and if concrete grade is M20, grade of concrete is M20, what is the value of sigma CBC? Please give me the answer. And grade of steel is Fe415. What is the value of sigma ST? So anyway, please look. I'm trying to solve with you. Please try to solve with me. M20 grade concrete is given to you. What is the value of sigma CBC? Please tell me the value of sigma CBC. And Fe415. What is the value of sigma ST? What is the value of sigma ST? Please tell me, guys. What is sigma CBC and what is sigma ST? And please do like, share, subscribe with as many people as possible. What is the value of sigma CBC for M20 grade concrete? AJ Arunachal, you're not there. AJ is from Karnataka. He says he's from Karnataka, but he's talking in Hindi. I don't know why. Does he look like a Hindi guy? Aravind AJ 140 for steel. Fe415 140 Newton per mm square. And M20 sigma CBC. For M20, what is the value of sigma CBC? What is the value of sigma CBC? For Fe415, sigma ST is 140 Newton per mm square. Well and good. What is the value of sigma CBC? I'm not going to give the answers. You should give me the answer. What is the value of sigma CBC? That is, what is the stress in the concrete? Maximum stress in the concrete. C or sigma CBC, whatever it is. 140 for steel. And what is that question mark first of all? You want me to solve that or what? Directly you're giving MU. That's good. So sigma CBC you're taking it as 7 Newton per mm square. And what about sigma ST? For FV415 it is 140 Newton per mm square. What is the value of FV? For FV415 what is the value of sigma ST guys? 140 Newton per mm square. For FV415 what is the value of sigma ST? Sigma ST what is the value? No comments. Sigma ST is it 140 Newton per mm square? If you say if it is 140, I'll go with 140. If you want me to change, let me know. Sigma CBC is 7. Sigma ST, what is the value of stress in the steel? Stress in the steel. This is FE415. What is the value of stress in the steel? What is the value of stress in the steel? Because Arunachal has said 140 and he has given question mark. Are you sure it is 140 or what is the value? Let me know. What is the value of stress in the steel? AJ, you have commented sigma CBC is 7. You don't have to write sigma ST. You can write stress in the steel or just comment the value, man. What is the value of stress in the steel? For Fe415, it is 140 Newton per mm square. Then for Fe250, what is the value? Fe250 is mild steel. This is HOSD bar. What is the value? What is this, guys? You are not commenting. I am not asking D value. I am asking what is the stress in the steel. Maximum stress in the steel. Isn't it audible, AJ? What is the maximum stress in the steel? Sigma ST value for FV415. I am asking for FV415. What is the value of sigma ST? Sigma ST is 140 Newton per mm square. Are you sure? And for FV250, what is the value? For FV250, what will be the value? So, for FV415, it is 230 Newton per mm square. For FV415 it is 230 Newton per mm square. For FV250 it is 140 Newton per mm square. FV250 it is 140 Newton per mm square. Please be clear. Sigma ST over here is 230 Newton per mm square. Without knowing that, how will you solve the questions? For FV415 it is 230 Newton per mm square. For FV250 it is 140 Newton per mm square. Without this, how do you think you will solve the question? So first of all, you must know the depth. Generally, overall depth by span ratio. Overall depth by span ratio you should know, that is generally equals to span upon 10. So span is given to you. Effective span is given to you is 8 meters. That is 8000 mm upon 10. So that is approximately 800 mm. 800 mm. So effective span, you can take this as the overall depth or effective depth also. Effective depth you can take it as span upon length. You can take this as effective depth. This is effective depth. Effective depth would be equals to 800 mm. So small d. You can take this as overall depth also, and you can take this as effective depth. Generally, it from exam point of view, I am just saying you can take this as effective depth. Effective depth, because many cases you will find it difficult. That is equals to span upon 10. So that is 8000 upon 10. That is equals to 800 mm. And will provide an effective cover. Effective cover. Assuming miles, nothing is mentioned, so you can take provide 50 mm. So overall depth would be equals to 800 plus 50. So that equals to 850 mm. 850 mm, right? So we can d equals to 800 plus 50, that is 850 mm. This is just an assumption, right? Whether this is correct or not, for that you should go, fine, you should check it. Now what is the bending moment? Effective. Now what is the dead load? Dead load. Dead load. If you have to calculate what is overall depth, overall depth is 850 mm. You can take it as 0.85. I'll give you the dead load would be equals to d multiplied by b multiplied by 1 meter length multiplied by density, that is 225. Depth is 0.85 multiplied by width. Width is 0.3. 300 mm multiplied by 1 multiplied by 25, that is equals to 6.375 kilonewton per meter. He has given 6.375 kilonewton per meter. And live load is given to us 12 kilonewton per meter. Overall load would be equals to live load plus dead load. I'll write it as WL, that equals to 12 plus 6.375, that equals to 18.375. Now what is the bending moment? Bending moment would be equals to WL square upon 8. This is where for a uniformly distributed load on a simply supported beam. For a uniformly distributed load on a simply supported beam, bending for a uniformly distributed load on a simply supported beam, bending moment is equals to WL square upon 8. W would be 18.375. L is 8 square upon 8. What is the bending moment you are getting? Bending moment you are getting is 147 kilonewton meter. Bending moment you are getting is 147 kilonewton meter. But we have to design it over here. Whether assuming that as what he is saying, balanced section by using WSM method. So WSM method, bending moment would be equals to, you can simply write QBD square, right? You can simply write QBD square, right? You can simply write that as QBD square. So whereas bending moment here, you will be getting 147 into 10 to the power of 6. Q is generally given as half K J K, or sometimes you can write it as N also. NC, that is critical depth of neutral axis, multiplied by sigma CBC multiplied by B into D square. So K value, how will you get? Just now we have calculated M upon M plus R. So this is equals to, how will you calculate R? R equals to sigma ST upon sigma CBC. Sigma ST is 230 upon sigma CBC. What is the value of sigma CBC? 7. So what is the value of R? Please tell me what is the value of R. Please tell me what is the value of R. Please tell me what is the value of R. M upon M plus R. So what is the value of R, man? 230 by 7. What is the value of R? R value is 32.86. And what is the value of M? M, sir, M is given to you in the question. Is M given to you in the question? M is not given to you. How will you calculate M now? M value, how will you calculate? M equals to M equals to M equals to, how will you calculate M? I'll write it over here. M equals to 280 upon 3 sigma CBC. So that equals to 280 upon 3 into 7. What is the value of M you are getting? 280 upon 21. What is the value of M you are getting? What is the value of M? What is the value of M? Please give me the value of M. प्रकार श्रृंखला pull out test क्यों करता है? Which pull out test you are talking about? Suddenly, which concept here? RCC or geotechnical engineering? I'm asking what is the value of M? You're saying all these things, you're asking different question. M equals to 13.33. AJ, I'm asking the value of M, man. What are you giving me? 13.33 plus 32.86. What is the value of K now? What is the value of K? 13.33 upon 13.33 plus 32.86. What is the value of K? K equals to 0.289, and J equals to 1 minus K by 3. So 1 minus 0.289 by 3. What is the value of J you're getting? What is the value of J you'll be getting? Please let me know. What is the value of J? Pull out test from concrete you're saying. It is generally used to measure compressive strength of the concrete. Generally used to measure the compressive strength of the concrete. It's indirectly related to the last class I have discussed the development length and all those things. So pull out strength is used to find the compressive strength of the concrete. In simple words, if you want me to say. J value you are getting it as 0.91. Now finally, bending moment. that is 147 multiplied by 10 to the power of 6 equals to half into 0.289 multiplied by zero point 0.9 multiplied by 7 multiplied by b is 300 multiplied by d square. From this, what is the value of d you're getting? Please give me what is the value of d you're getting. D value. What is the value of depth you're getting, guys, from here? What is the value of depth? Depth you're getting somewhere around 733.65 mm, which is less than 800 mm. That is what we have provided. So our design is safe. Design is safe. So you can provide approximately 740 mm now. So D value that can be provided is 740 mm, and cover, effective cover is 50 mm. Overall depth would be equals to 790 mm. In simple words, overall depth would be equals to 790 mm. Fine. Now the idea is to find out what is the uh, you know steel. We have calculated depth. Now idea is to find out what steel. So simply by equating compressive force equals to tension force, you can easily find out that one. So B multiplied by K into D multiplied by half sigma CBC. Half sigma CBC. Half sigma CBC. That would be equals to tensile strength. Tensile strength is simply sigma ST multiplied by AST. So B value is how much? You can write this as 300 multiplied by K. K is 0.289 multiplied by 740 multiplied by half multiplied by 7 multiplied by sigma ST is 230 multiplied by AST. What is the value of AST? What is the value of AST from here? What is the value of AST from here? What is the value of AST? AST equals to how much you are getting? 9 976.31 mm square. This is AST. So what is the number of 16 mm dia bars? Just give me number of find number of 16 mm dia bars. Number of 16 mm dia bars AST upon pi by 4 multiplied by 16 square. So number of 16 mm dia bars, guys. What is the value of AST? Number of 16 mm dia bars. Please let me know the number of 16 mm dia bars. 6 bars. Fine. 6 bars. So you'll provide a depth of 790 mm means 800 mm. You can provide an AST of 660 mm dia bars. That is the design. So finally, what you have to do is you have to just draw a figure showing all these things. 6 bars. So I'll draw it here. 6, 3, 4, 5, 6, and overall depth we are providing it as 790 mm. overall depth is 790 mm and effective depth is 740 mm, and this is 6 numbers of 16 mm dia. 5 bars. You said 6, now you are saying 5. Please do the calculation correctly, man. I'm believing you and you are doing these things. Sorry, he's saying 5. 5 bars of 4 point something if you are getting, then it is 5 bars. 5 bars. I don't have answers with me. I'm just believing you blindly. Please do once again and tell me the answer. 5 bars of 15 mm dia bar, 16 mm dia bar, 5 bars of 16 mm dia bars. Please don't do calculation mistakes here. After working hard for these many months and doing everything at the end, don't do calculation mistakes. Final answer, they'll see, if they see like you have drawn a diagram where 790 mm or approximately 800 to, like there is a fusion of 750 to 850, they'll see that, and if the figure is correct, they won't check everything, they'll just give you 10% marks. Believe me, the final figure that you have drawn, if it is correct, they'll give you 100% of marks. If there is anything wrong in that, or if you haven't drawn the figure also, then also you will get less marks. So try to draw the figure at the end. You just have to show, okay, 300 mm by approximately 800 mm. You have given a cover, you have given 750 mm, you have given 5 to 6 mm, 6 numbers of 16 mm dia bars. If the examiner, or sorry, if the whoever the correcting the paper have seen this, he will give you 10% of marks. 10% of marks. Fine, guys. Any doubts in this? Any doubts in this? Please let me know. Here, by using WSM concept, we try to find out what is the moment of resistance. So here, an 8 meter slab is given to you. Based on that, first we try to calculate what is effective depth. Effective depth by span ratio is generally taken, there is a range 1 by 10 to 1 by 15, something like range is there, but generally you'll take it as 1 by 8 to 1 by 10 also you'll take, but here I'm taking it as span upon 10. From this D value I got 800 mm, effective curve 50 mm, so overall depth I have given 850 mm. From that I have calculated what is dead load, live load, and bending moment. Bending moment for simply supported beam is WL square by 8. From the bending moment, I try to calculate what is, because he said balance section, so N or K, critical depth of neutral axis, M upon M plus R, M equals to 280 upon 3 sigma CBC, and sigma ST equals to 230 Newton per mm square. From that, M upon M plus R, J value I have calculated. From this, I have calculated depth. Depth I got 740 mm, which is less than assumed, therefore it is safe. So 740 mm you will provide with a cover of 50 mm, so D would be 790 mm only. And from that, AST I have calculated. AST, as you said, it is 5 number of bars. So 5 bars of this much mm. So 5 bars of 60 mm dia I have got. Always remember, please draw the figure at the end. If figure is correct, if they are asking you to design and if figure is approximately correct, they will give you full marks. They won't check all the process, because they come to understand that you know the concept, then only you have drawn the figure. So figure helps you at the end. You have to just note it down like 300 mm, 740 mm, 790 mm, 5 numbers of 60 mm diagram. Sometimes your assumption changes and many things changes, but it should be in the range. Like where he'll provide you a question of 800 to 900 or 750 to 850 or 4 to 6 6 numbers of 6 mm diabars. If it is in the range, he'll simply tick it and he'll give you full marks. Fine. Any doubts in this, guys? Please let me know if you have any doubts in this. If you have any doubts in this, please let me know. In today's class, we have discussed in LSM how to design the beam in LSM, how to design beam, how to find out moment of resistance in LSM, how to design beam in WSM, and how to find out moment of resistance in WSM. 4 questions I have discussed over here. So how to design beam in both LSM and WSM, how to find out moment of resistance in both WSM and LSM. See, the concepts is also covered over here. Concepts is also covered over here. We are not wasting the time. I know that your time is precious and I'm not wasting your time at all. I'm not wasting your time at all. So remember that, okay? Any doubts in this, guys? Any doubts? Minimal doubts you can question. You can question me. And that guy, Rakar Sankala, I told you an RCC pull-out test is used to find out, compressive strength of concrete. That is generally based on development length concept, where if you know the bond strength, you can find the compressive strength of concrete. That is the idea over there. Anyway, any doubts in today's class, guys? Any doubts? And apart from any doubts in today's class, you can ask me any other doubts. Any other doubts as well. Your next class will also be based on SSC conventional questions only, because here I have discussed RCC, the other concepts like in RCC beam I have discussed over here. Other things I'll be discussing in next class also. So apart from today's class, if you're having any doubts in today's class, you can ask me. If you're having any doubts apart from today's class, that also you can ask. You can ask me, okay? So please let me know. Please let me know, guys. And is this timing okay for you? You want me to change it to from morning 6 to 8? 6 is too much early, because there are certain people who will might read in mornings also. Certain people who read in the nights. It depends whether you are night owl or early rooster. Any doubts, guys? Any doubts? WSM based on stress, LSM based on strain. No, both WSM and LSM are based on stress strain curves. It's not like WSM is based on stress, LSM is based on strain. In both the cases, the strain diagrams will be linear, whereas the stress diagram would be different. That's it. If you're taking any beam, for a case, strain diagram in WSM, if this is the strain diagram, stress diagram will also be like this only. This is the level of steel. This is the level of steel. If this is strain diagram, if this is strain, this is stress. Stress and strain are linearly proportional. This is in WSM. Whereas in LSM, strain diagram will be linear. Whereas stress diagram will be different. It would be something like this. So you can't simply say that it is based on stress and it is based on strain. No, you can't say that. This is strain diagram and this is stress diagram. It is based on both stress and strain diagrams. This is limit state method. So no, that is wrong assumption. WSM and LSM both are based on stress and strains. So any doubts in this, guys? Any doubts? Anything else you want to discuss, you want to say? As I always say, eat, sleep, study, repeat. You can take breaks, but not long breaks. Tomorrow is Sunday. That doesn't mean you can rest whole day. WSM underestimate the strength of metal. That's why sections are uneconomical. That is true. WSM sections are always uneconomical. You provide larger depths or high amount of steel over there. Whereas in LSM, you'll provide economical, but there won't be much difference here. Finally, you'll come to WSM only. Initially, they thought they might show some difference, but right now people are trying to be in safer side and they are going for Indirectly, both from WSM and LSM, they are trying to provide same depths only. They are not taking that cushioning, or they are not trying to go for that risk. Any doubts, guys? Anything else? Anything else you want to discuss, or we can wind it up today's session? Please let me know if we can wind up today's session. I'll wind it up. Anything else you want to discuss? If you want me to wind up today's session, please let me know. I'll wind up the session. We are not going to discuss any questions anymore. If you are having any doubts, please let me know. For SSC JE mains it is conventional questions only, no? That's why I'm discussing conventional questions as well. But recently they are changing it to objective. They are saying that they are changing it to objective, but we exactly don't know what you are going to expect. What is that you want to ask? Objective. Yeah, I know that. If they suddenly change it to conventional, what will you do? So, keeping that in the view and discussing conventional questions as well. And here also you get the concept, the same concept will be used. Initially it was conventional, they have changed it to objective. If objective was good, it's fine. But if not, the concept will remain same. So I'm just trying to discuss concepts through previous year's questions. That is the idea. When I'm discussing PYQs, that only doesn't mean that this is for conventional questions, but I'm discussing concepts through it. So indirectly, I have shown you how to calculate moment of resistance, how to calculate these things. That is the idea. Main idea is that. You want only objective questions? Last time I tried, yeah. ठीक है मैं कोशिश करूंगा from next class hopefully, or if not for next class, after that. That means I think Monday is my class. If nothing goes wrong, I'll discuss it on Monday. But if something goes on that way, then I'll discuss later. But I'll make sure that it will be only objective. So if not SSCJ, I'll try to solve, because if you see SSCJ means there is no many objective questions. That means then I have to discuss gate questions over here. But I'll try to get as many questions as possible, and we'll make sure that you'll solve it. Yeah, my idea was that, but people thinks it's waste of time as well. Anyway, I'll try to make sure that I'll solve objective questions. I wanted to discuss concepts, so I can't teach it through. I can't teach the concept and make you solve the problem. So I thought this will be a better way. This is only for the people who have already studied and have done their revision. It will be useful for that people, not for the people who are studying. Now, right now. हाँ जी हाँ जी मैं अभी कर रहा हूँ बट आई डोंट नो अबाउट फ्यूचर लेकिन अभी मैं सारे सब्जेक्ट्स डील करता हूँ Okay, guys. So for now, I'm winding it up. And good night, guys. All the very best. Huh? Fine. We'll meet in the next class. Bye. Bye, AJ, and bye, Arunachal. Good night. And AJ, I'll remember. I'll make sure that we'll solve as many objective questions as possible. But since the objective pattern is new, you'll get very less questions. So we'll discuss other questions as well. Okay. From mains point of view, I'll discuss. Okay. Bye. Good night.